Can you hear me? If you can hear me, just acknowledge in the chat. Cool, cool. I'm getting a couple of messages saying yes. So I wanted to take a moment to quickly introduce the webinar. My name is Kashyap. I am part of the Clarion call organizing team. I otherwise work with pepperfry.com in marketing and various business roles. Today we have a masterclass, a workshop from the AWS team. We have two speakers from AWS with us today. There is Setu Satyan and Satish Hariharan. Both are from the AWS team that works with startups and helps startups to scale. And they will kind of take us through their ideas and thoughts and the subject of the topic. I'm thinking that the overall one-way communication kind of will take about 55-60 minutes. So we'll leave about the last 25 minutes or so available for available for Q&A. As far as Q&A is concerned, you can ask questions as the webinar is progressing, but my request is to hold on to it, and when I throw open the forum for Q&A, if you type it then it'll be easier for me to track it and to ask the questions to the speakers. So if you can just hold on to your questions, probably make a note of it and then ask it towards the end. It'll just make the process a little bit smoother. Wanted to introduce the two speakers. There is Setu Satyan from the AWS startups team, and she will go first. I'll allow her to give more details and talk about it herself. And following her would be Satish Hariharan, who is taking the masterclass. Over to you, Setu.
Thanks a lot, Kashyap. Hi, everyone. Let me just share my screen. Let me know if you can see my screen.
Yes, we can see it.
Okay. All right. Yeah, thanks, Kashyap, for the introduction, and thank you everyone for joining. Happy to be here and to interact with startups that are part of Clarion call. So I am Setu Satyan. I'm part of the early stage startup team at AWS. I'll just take quick 5 minutes to give you a brief about different startup programs that we have and resources that are available to you. So we are not just a technology company, but we also have a dedicated startup team that work with accelerators, incubators, and startup programs across the globe. So our team consists of people who are like exited founders, former investors, startup mentors, or people who were part of the ecosystem earlier. So as you can see, some of the partners which we work across the globe. So we are committed to helping startups that are part of the our partner portfolio in accelerating their growth in both in business as well as in technical side. So what exactly does our team do? We don't invest any cash or take a capital position, but we do invest our time, resources, promotional credits, also share our experience, knowledge, and open doors for you, remove any obstacles to anything that could help you accelerate the growth. As Amazon, we also leverage our global footprint to connect you with the right resources whenever required. These are some of the programs which we have currently. As you can see, all these programs are categorized depending on which stage your startup is in. I'll quickly go through some of these which could be relevant to you, but majorly you can see AWS Activate is there, startup migrate programs, credits and trainings available. So I'll just take a quick 2 minutes to go through each of these. So the first one is the AWS Activate, which is available to early stage companies. So early stage companies are those which are either self-funded or bootstrapped or seed stage to up to Series A. Through this program, startups receive a certain amount of credits and also business support credits. It also comes with self-paced labs, other SaaS solutions powered by AWS and Activate Toolbox. So startups that are a part of Clarion Call, some of you are eligible for the Activate program. You can reach out to the Clarion Call team for more information on this. Next is the startup migrate. So if we help you migrate from another platform, here we do the heavy lifting for you to lift and shift your workload to AWS. We also support you throughout the journey by supporting you with some credits and free trainings. So if any of you would like to explore this, you can directly reach out to us post the event. We also have a dedicated team of experienced solution architects who work with the startups. So if you want your architecture to get reviewed, or if you have before launching your product or any idea which you would like to discuss, we have a team of dedicated solution architects to help you with that. Apart from this, we also host a bunch of solution architect workshops throughout the year. Next is the AWS Business Support, which comes with the Activate program, which I mentioned earlier. So through this premium business support, you will get access to AWS Trusted Advisor. You can also get access to white papers or case studies or any architecture guidance that you require. Moving on to the cost optimization part. So if you are a startup who are looking to scale, and then if you need help with optimizing your cost or optimizing your architecture in terms of security, operations, or performance and reliability, we help you with that. So we have different tools which are available for that. And also we do a lot of workshops around this to train you around this. And of course, our solution architects are also there to support. This is another interesting program that is available to startups. So it's called AWS Connections. So here we basically do a matchmaking between our enterprise customers and the startups in our network. So whenever there is a requirement from one of our enterprise customers, be it a use case for any business or technical challenge, we always reach out to our startup companies and see if there is a fit. So once we find the relevant startup, we make the connection, and also we ensure that we always do the right matchmaking. Next is a program for startups which have physical products. So if you want your product to be listed on Amazon.in or any support around those, there's a program called Amazon Launchpad. You can check out the website for more details, but the program help you with onboarding, marketing support, and any other operational support that is required throughout. You will also get access to some amount of Activate credits as well in the program. Amazon Alexa team has also set up a program called Alexa Fund, which actually invests $100 million in venture capital funding. So this program is for startups or developers or groups that are innovating in voice technology space. For example, if you're a company that is building technology for Alexa or innovating in the areas of say artificial intelligence or text-to-speech or voice recognition, then you can check out this program. This program is open to everyone, all the startups, like if you're just getting started or if you have an established product. So the program provides you with early access to SDKs, hands-on development support, and also showcase you at some of the Amazon global events as well. So you can check out the Alexa Fund website for more information on this. Yeah, so that's about the quick overview about the programs. If you have any questions, let me know. Or like I mentioned, if you would like to get connected with an architect for any reviews or any other technical support post the event, you can directly reach out to me.
Thank you so much, Setu. I think it's now over to Satish to kind of take us through the main masterclass subjects today.
Satish, you're on mute.
Sorry. No matter how many times you do this, you end up doing the same mistake. Sorry about that. My name is Satish. I'm based out of Bangalore, India. I'm a solution architect with the startup ecosystem team. I have around 25 years of experience in technology. I used to be with Wipro Technologies earlier. Founded a couple of startups, so been an entrepreneur, and I've seen the challenges in building and distributing systems to customers and trying to build consumer platforms and so on. Been with AWS for the last couple of years, and in my current role, I kind of help startups, with their architectures, with their understanding of AWS technologies. There is quite a lot when you look at AWS as a platform. So helping customers pick the right building blocks and optimize their architecture from a security standpoint, from a cost standpoint, from a performance standpoint, and so on is what I do on a day-to-day basis. So I will be happy to walk you through or review your architectures as well post this session. During this session, I'll be kind of covering what's relevant for early stage startups. I'm going to kind of share my screen. Probably I'll stop the video now. So I understand that most startups here are sort of early stage. So what I've done is create an agenda for building and scaling fast on AWS. So we look at this agenda. Hopefully I'll be able to cover this in an hour. So given that some of you may not already be on AWS or just getting started, I'll be introducing AWS to you, the global infrastructure and so on. We will look at the breadth and depth of services. There are close to 180 plus services on AWS today in around 15 different categories. We will look at a few categories that are most frequently used and look at some of the services there. And I will try to cover some of the philosophy behind why these services and how they're organized and so on, so that you get a big picture of the services itself. Then what I'll do is not every solution requires you to pick and choose from various categories of services and put those building blocks together. So we'll look at a few reference architectures that we have documented based on our experience working with tens of thousands of customers over the last many years. And we'll see how customers put some of these solutions together and the best practices around that. Then we have something called solutions, which is an offering where you can kind of deploy a full solution end to end in AWS with just a click of a button, and get everything up and running in a few minutes. So we'll look at that and see how you can make use of those. And I'm thinking I'll just do a little demo also on that. And lastly, I will cover AWS and Amazon's philosophy of product development in the cloud. How do we build our services, because we are also providing cloud-based solutions to consumers, right? So what is our philosophy? How do we organize ourselves? How are we able to deliver features fast to our consumers? So that we will cover that as well. And lastly, I'll give you a few references that you can pick up and read and take your journey further. So to get started, before you understand or start building on AWS, you need to understand our global infrastructure. Today we are, as you know, AWS is basically a set of data centers that are located across the globe, right? And it's clusters of data centers. Currently, we are present in 25 different regions across the globe. In India, we are in one region as of today, that is in Mumbai. And we have already planned for another region, which is going to be in Hyderabad. Hopefully, it'll be operational sometime next year or end of next year. So that's the plan as of now. The other thing that you need to be aware of is every region, when we say, Mumbai region, it's usually not one data center, but it's a cluster of centers. So in Mumbai itself, we have 3 different data centers, and each of these we call availability zones. So in Mumbai, we have 3 availability zones. Each of them are connected through dedicated network, and the latency between these centers is very small. But these are also centers which are separated geographically, so that even if one center goes down, you can architect a solution in such a way that it continues to run on another center and your services or your applications are not impacted. So it's important for you to understand the concept of availability zones. We have close to 80 availability zones across the globe. And the last thing that you need to be aware of is something called a point of presence. So this is again a physical location by AWS connected to our dedicated network. But this is not a data center, it is an edge location from where you can serve your content. So if you have a website, you have the ability to serve that particular content of that website from the closest available location from your end consumer. So if somebody is in Chennai, they can actually serve content from Chennai or Kolkata for that matter, right? So there are around 16 of these in India itself. And again, we keep adding more and more of these edge locations. So this is basically a content delivery network for you. So that's pretty much what the global infrastructure is about. And all of these locations are actually connected through a 100 gigabit Ethernet network. Sorry. Right. So it's again, the network itself is redundant. Even if one of it gets cut, it doesn't impact your services. So this is something that you need to be fully aware of as you try and build your solutions on AWS. The second thing that you need to be knowing is, now that you know the infrastructure that is there, what do I build? And how do I bring my applications on top of these centers, right? So there is close to 180 plus services that is available to you for you to build. So you may, if you're already using, you may be, you may have heard about virtual servers, EC2 instances, and S3 database storage and databases and so on. All of these services are categorized in 15 different categories. We will look at a few, 4 or 5, which are most frequently used by our customers, so that you get an idea of what these mean to you, right? So jumping into the first one, most customers start with using a compute server, right? Talking to so many startups, I see many of them spin up an EC2 instance. EC2 is one of the first services that AWS launched as a service. Basically, it allows you to spin up a virtual server instance in the cloud, and you can access it over the internet, right? This is where most of your business logic resides, and it's usually the foundation of most innovation. But if you look at compute itself, within AWS, you have today 3 ways in which you can deploy your business logic. One is spinning up a server using EC2. Second is using containers. In the last few years, we have seen more and more customers using a container as a way to deploy their servers or services onto the cloud or even on-prem, and make them available to their end customers. Container is something that you can kind of package. You can think of it as a very lightweight OS that can be easily started and stopped, and it can be deployed across multiple clouds as well, or even on-prem. So it offers you the flexibility to kind of create a package and deploy it wherever you want. So that in turn has led to adoption of containers in a rapid pace in the last few years. And the last way that you can deploy compute or business logic in AWS is using a service called Lambda. Here, what customers usually do is write a function as a service. So again, this business logic, you can write your business logic in many programming languages. It could be Python, it could be Java, it could be Node.js, it could be Ruby, and so on. And you can even bring your own custom runtimes. And Lambda, what it does is it allows you to run a function as a service. So the thing here is that all you need to be bothered about is the business logic that you write within a function, and you don't have to bother about the underlying infrastructure. AWS takes care of it completely. So as you move from the left to right, the operational responsibility of managing a server moves from you, the customer, to us, AWS. So this is again, it's something that it's a mental model that you want to keep as you try and build your solutions on AWS compute. So we looked at Lambda as a serverless option, right? Where all you need to do is write a function. So rather than just compute, what we also do is we provide serverless components in various categories. So if you want to use storage, let's say you want to store your video files, audio, or JavaScript files, websites, and so on, you can use a service called Amazon S3, which is a fully serverless storage option. Similarly, you can use DynamoDB and Aurora serverless databases for databases. This is, you can use this for a key value store. You can use Aurora for SQL databases. Similarly, you can use something called Amazon API Gateway to build a REST API proxy. Some customers want to use messaging when they build microservices. They want to communicate between microservices using messaging kind of infrastructure. So we have services for doing that called SQS, which is a first in first out queue. There is another service called SNS, which is like a publish subscribe mechanism. Similarly, there are services for doing analytics. There are ways to orchestrate Lambda functions. There are ways to monitor and debug your services. There is way to deploy your code to edge compute as well in IoT devices and so on and so forth. So when you think of serverless, you have to think about a bigger portfolio of components that you can stitch together to build end-to-end solutions. Next, we look at a category of databases. Again, traditionally, if you look at maybe 5 to 10 years ago, most customers started with using a relational database for storing their data, right? We used to create relational models and use something like Microsoft SQL Server or Oracle, for that matter, to hold our persistent data. But what we see as a trend over the last few years is customers want databases that are purpose built. So what that means is a relational database used to provide asset properties like consistency and durability and so on, right? So that's what was needed at that point in time. But as you see, in the current world of consumer applications, social graphs and social networks, and so on, consistency may not be the one to optimize, right? Sometimes it is availability. So customers need different types of databases that suit the data that they actually are trying to model. So AWS also has embraced the same idea of database freedom, and we offer purpose-built databases for the tool as a tool for the job that you need to get done, right? So today, if you want to store key values, we would recommend you to use something called Amazon DynamoDB, which is a database that provides you single-digit millisecond latencies. If you want to store JSON documents, which are similar to with an infrastructure which is similar to MongoDB, we would recommend you to look at Amazon DocumentDB. Similarly, many customers want to use in-memory stores. So we have a service called Amazon Elastic Cache, which implements open source infrastructure, which is Memcached or Redis as a service, which you can use for your caching purposes. Similarly, a lot of customers may want to build social networks or knowledge graphs and things like that. So we have a database called Amazon Neptune that allows you to build a graph database. There are also very domain-specific databases that are available. For you to say store time series data, you can use something called Amazon TimeStream. Banks, again, sometimes need data that is immutable, like a blockchain, right? So we have a database called Amazon QLDB, Quantum Ledger Database, that customers can use to handle immutable data. So the philosophy that we have from a database standpoint is look at what fits the purpose and use that for the job that you have to do. So apart from that, we also offer relational databases, which you can use for your SQL relational kind of data, and that again comes in multiple flavors. MySQL, PostgreSQL, and MariaDB are our open source flavors, and Oracle and Microsoft SQL Server is also available. Apart from that, if you would have seen in the previous slide, we also offer a serverless version of MySQL and PostgreSQL, which startups find very interesting because they don't really have to manage underlying servers in this case. You just need to specify how much compute capacity you need, and you get charged only for the actual usage of these databases. Now let's look at another stack. This is a fast-growing area within AWS, the AI and machine learning stack. We had, if you look at 3 or 4 years back, the number of services that were there here was much smaller. But as you see, every year this space keeps growing, and that's because of the demand that we have from customers. Now, if you look at the AWS ML stack itself, again, one way to look at this is what is the kind of team that you have. So the vision for AWS's ML is to get machine learning in the hands of every developer. But as you look at teams, early stage teams usually have a few developers. But as startups grow, we typically see that they build a team of data scientists. So now, if you want to build core capabilities in machine learning, or even if you want to build features that improve your efficiency of operations through machine learning, we see that startups build out data science teams for doing this job. And as startups grow from that to larger organizations, they also have machine learning experts who tend to use underlying frameworks like TensorFlow, MXNet, and PyTorch. So the way that we have organized our ML stack is to be able to cater to each team persona. So if you look at it, we have 3 layers: AI services, ML services, and frameworks and infrastructure. Now, if you have a team that has machine learning experts, you would typically start with this stack. You could be using TensorFlow, MXNet, and PyTorch directly, and you can use our deep learning machine images to build your machine learning models. Now, if you have a team that has data scientists, data science folks who are familiar with Python, they want to use frameworks, they want to build models end to end, and you want to build a deep learning pipeline, we have a ML service called SageMaker, which comes with an integrated development environment that allows you to build deep learning pipelines end to end. You can start from data engineering to training of models. We provide around 17 different algorithms that you can take off the shelf, train your models, deploy your models, and get your services up and running. Now, if you don't have a data science team, but you still want to use AI services, you want to add personalization, let's say, or you want to do forecasting. Let's say you're an e-commerce company and you want to optimize your supply chain and you want to forecast demand. You could still be using some of our AI services, send data to this AI services, build the model, and simply call an API. In this case, you don't really need to build a model of your own. All you need to do is send relevant data to some of these services, and you can directly call an API to take advantage of some of the capabilities that bring to the table, like personalization and forecasting, computer vision, and natural language processing, and so on and so forth. So if you just have a set of developers, would recommend you to explore the AI services that they bring to the table. So that's kind of a mental model that you may want to keep as you explore our machine learning stack. The next one is something that we have for analytics. Again, this is companies who are at scale typically want to look at the data that they're gathering from their customers and do analytics on top of the data that they have. So there are 2 ways in which companies bring the data into a storage layer, and we call the storage layer a data lake. And the 2 ways is, one is a one-time data movement from maybe an on-premise environment. The other is a real-time data movement. So you could have something like IoT sensors that are out there, right? If you're Uber or a startup that is running on with automobile capabilities, right? You could be having IoT sensors sending live data. Or you may be looking at social media feeds and so on, and you want to get analysis of sentiments and stuff like that. So you may want to move data real time as well. So we have services that allow you to do that. But the core philosophy is that we use is for you to build something called a data lake on AWS using a service called S3. What you do is you bring all the raw data either structured or unstructured into an S3 data lake. Then you do something called an ETL transformation, an extract, transform, and load transformation using various services. And once you have the transform data, you can then utilize that for the purposes of machine learning using the services that we spoke about previously, or using a set of services within our analytics portfolio. Again, within analytics, you have the ability to do interactive SQL queries through a service called Athena. If you want to do map reduce jobs, right, on big data, there is a service called EMR. If you want to move data to a warehouse, a data warehouse, there is a service called Redshift and so on. So these are some of the capabilities that you need to be aware of if and when you want to do analytics on AWS. Lastly, looking at one more category, again, automation and DevOps is very critical for you to build your business and move fast, right? If you are building something on-prem, you are probably aware of these 4 stages of the life cycle, right? Source, build your source code, build it, test, and deploy it, right? This is core to a continuous integration or continuous deployment pipeline. But as you move to the cloud, you also have 2 more stages that is possible. Given that cloud infrastructure is software defined and you have infrastructure as a service, you today have the ability to actually provision infrastructure also on the fly. So whenever you make a release, you can provision new infrastructure and you can then monitor that infrastructure as well. So most of our customers, when they make a new release, the way they go about it is they do a continuous integration pipeline through services like code commit, code build, code deploy, and so on, that allows them to do this. And then they provision the necessary infrastructure for them to deploy their software and then get it running and point the production endpoints to just what was provisioned newly, right? And then they just pull down the previous endpoints that were already available. And you also have a way to monitor all this. So there is a set of services that allows you to do this. One of the key services for you to explore is something called CloudFormation that allows you to provision your infrastructure. And once you have provisioned, there's a service called CloudWatch that allows you to monitor this as well. CloudWatch allows you to capture logs. It allows you to create metrics. It allows you to create alarms and so on for you to closely monitor your infrastructure. So this is pretty much the different categories of, the most frequently used categories of services within AWS. Now that you have an idea of what are the big categories and what services fall into these categories, we will look at a few reference architectures and see how customers use these services, right? Every single solution needs you to bring the individual building blocks from each of these categories and then put them together to get a solution going, right? So one of the simplest solutions that customers use is to build a RESTful microservice. A lot of customers use a solution such as this. Here, what you're trying to build is to build an API, a RESTful API for your end consumer to utilize. For that, you can use a service called Amazon API Gateway, which allows you to create RESTful services, right? Amazon API Gateway can be connected to the compute service that we spoke about earlier, called AWS Lambda, right? Now, Lambda, you can write programs in multiple programming languages and use SDKs within these languages to persist your data into any data store. In this case, we are talking about Amazon Dynamodb, which is a key value store, but this could be any one of the many databases that we spoke about earlier that you could potentially use. So this is like a very simple architecture for building a RESTful microservice. Now we will look at another one. This is a serverless web application. Let's say you want to build a website which you load from a backend, which has JavaScript files and HTML and CSS and so on. It also needs to call an API and it needs to persist data into a database. You would typically use a service, a storage service called Amazon S3. You would This is actually object storage. You can store files and videos and audio and so on. You would upload your HTML, CSS, and JavaScript into a storage like this, and you can directly access this from your web browser. You also have the ability to use our content delivery network, which is Amazon CloudFront, to access the data within S3. Once you load all of this into a web client, now you have the ability to make an API call from your web client using Amazon API Gateway, Lambda, and Dynamodb. This is nothing but the RESTful service that we just looked at a few seconds back. And this is another way to build a completely serverless web application. Many customers also have a need to authenticate and authorize their end users, and when they try and access their APIs, right? This can be made possible through a service called Amazon Cognito. Cognito allows you to create user pools and identity pools for you that helps you authenticate your end consumers through things like email and password-based authentication. It also supports multi-factor authentication, OTP, and so on and so forth. Cognito also allows you to connect with third-party providers like Google and Facebook that are OpenID compliant. You can even, in an enterprise scenario, you even can integrate Cognito with something like Microsoft Active Directory services. So given the building blocks that are here, it's very easy for you to build a serverless web application. And this is a very common pattern that we see with many of our customers. Now let's look at another use case. This is an example of stream processing. Here, the data moves from the other end, right? You're streaming information from an external source, and you want to do analysis of that data. This is an example of analysis of streaming social media data. Now, what you do is you would create some API calls into a service called Kinesis. We talked about this in our analytics slide, right? So you push all of your information into Kinesis. Kinesis allows you to load all of this and trigger Lambda functions, which is your compute layer. Lambda can again in turn write information into different kinds of databases. In this case, we are looking at Dynamodb again. And once it is in a database, you have again multiple services that can create dashboards and look at social media data and build trends out of this. So this is again another frequently used architecture that is used for stream processing. Next, we look at a batch processing architecture. This is again used by startups that are scaling up, and they are getting a lot of big data into their systems. Typically, what happens is, let's say you're a bank, right? You may be getting terabytes of data overnight, and you want to actually process that data and make that become usable in a format that other systems can consume. So typically, you may run a nightly job, or even a job every few hours. So a reference architecture like this allows you to orchestrate a job using AWS step functions. You push your data into a source data store like S3. You then orchestrate a cron job or a function that can pull this data, and you can use multiple compute offerings. AWS Batch is an offering that allows you to run container-based logic to do extract, transform, and load of source data into a data that you can transform that can be consumed. Similarly, if you want to do map reduce kind of operations, let's say you have a lot of data that is not easily processed by your middle layer, you may want to do distributed processing of that information, right? So we can use a service called Amazon EMR, Elastic Map Reduce, to transform that data into something that is consumable by your downstream systems. Similarly, one more service that is very easy to use is called AWS Glue, that allows you to create Spark jobs as well as Python based logic for you to take source data and consume that into and transform that into data that can be consumed by downstream systems. So this is another typical architecture that we see in a batch processing scenario for analytics. Now let's look at another architecture which gets used in an AI ML kind of a scenario. Here, one common use case is customers uploading images to your web application or some service that you have. Now you need to understand what is there in the image. So it could be KYC kind of application, or sometimes you may just want to take that image and create thumbnails out of those, right? So an architecture here is, customer uploads some information that goes into a service like Amazon S3. S3 can trigger a compute layer Lambda function. Lambda in turn calls an AI service that we spoke about in our AI ML stack, right? We have a computer vision service called Amazon Recognition that can be called from Lambda, and it can give you, information like image, facial details, and attributes, and so on. Now you can take that information, publish it back into Amazon S3 in a format that can be consumed by downstream applications. Athena allows you to do SQL queries on attributes that are stored here, and QuickSight allows you to create dashboards for you to view trends and so on of demographic details. So again, this is a simple example of how you can integrate an AI service into an architecture as a building block into a reference architecture. What we usually see is much more complex versions of this. We see customers build natural language processing capabilities into their architectures using Amazon Comprehend. Sometimes they may have information that comes in multiple languages. So they may be using Amazon Translate to convert that language into some kind of a language that makes sense for them to understand, and so on and so forth. So again, look at this as a a base reference architecture, but a similar architecture could be used for integrating with multiple AI services. So we looked at a few of those architectures, right? Now, there are certain use cases that are so frequently used by our customers that AWS and our partners, we have created this reference architecture to be clicked and deployed into AWS, into an AWS account within a matter of minutes. And we call this as solutions. So individual AWS services is something that you may use to build your own applications and put them together. Solutions is basically a combination of these AWS services we looked at, and even partner products for that matter. And we have specifically combined this for very specific use cases. These can be automatically deployed. Once you have an AWS account, you can just go to our solutions page, click on a button, and deploy these solutions for you to be able to use within a few minutes. All of these solutions are available or rather built using a service called AWS CloudFormation. And CloudFormation is the input for CloudFormation is a language called YAML, or it can use a standard language like JSON. And all of these solution templates are available as open source in these formats. Again, these are built by either AWS solution architects or our partners. And again, solutions are either IT oriented or business oriented. We look at a couple of examples, right? So an IT specific use case here is something we call an AWS Landing Zone. So this is usually focused on enterprise customers where customers use multiple AWS accounts to do their job. As a startup, you may be just using one account, but as you grow, right, you may need an account for your development teams. You may need an account for just billing and monitoring purposes. You may need an account just for logging data so that all of that information is available in just one place for you to monitor. Or you may have one account just for production, and you will stop all access or console access into that production account and so on, right? So we have created a solution called the AWS Landing Zone, which if you deploy, it creates all these different accounts that I spoke about and connects them together, and you can just start using them from day one. So this is a typical IT specific use case. Now we'll look at an LOB, a line of business specific use case. Let's say you have a need to, stream video or provide video on demand. So there is a solution called Media to Cloud, which you can quickly click and deploy, and it provides you the ability to very easily upload your video files into AWS storage and have a way for you to stream that information out to your consumers. So these are two solutions that are examples. What I will do is also, walk you through how to get to that solution. Just give me a minute. All you do is go to AWS Solutions. You can search for the AWS Solutions page. You can go into implementations, and as you can see, you have 300 plus solutions that are built by AWS and our partners. So let's say I want to do something in machine learning, right? I can then search for that, and you can see all our solutions which are around machine learning. Now let's say you are a startup, you want to create chatbots, right? You want to have a bot as part of your website. You can just go to our Serverless Bot Framework, which is a solution. You can look at the architecture for this, and you can look at how it is implemented. And with one click, you can launch the solution onto AWS. So you just need to be logged in and click a few buttons, and a serverless bot framework will be available to you in a few minutes. I actually created a solution in the IoT space. I just deployed something. So if you're an IoT startup, right? One of the problems that an IoT startup has is to be able to test their IoT solution with hundreds of devices. Now, you cannot have real devices to test this. You may need to kind of simulate this. So an IoT device simulator is a solution that we have. So I just search for a device simulator, and it becomes available, right? So I launch this with one click, and what I get is something like this. This is a full solution that is available to you, right? I created some device types which are like automobile, right? I create a set of attributes and so on and so forth. And then all I need to do is I just start using this. And this device simulator actually sends messages to certain endpoints that I can then use to test my IoT solution. So it is as simple as starting something, clicking on a few buttons, and getting something up and running in a few minutes. So that's around solutions. Now we covered services, we covered a few reference architectures, we looked at a solution. We will now look at how Amazon ourselves build our products in the cloud, right? And what is our philosophy around building systems, right? So many of you would have already seen this, right? As a startup, this is the lean startup methodology. Build, measure, and learn is a loop that you go through. And as every startup, you are searching for a scalable, viable business model, and you're trying to generate insights about your customers, right? What are those unmet needs that your customers are looking to solve, right? And where is it that you can provide a solution that can meet that that need, and how do you go about doing that? And the key here is how fast can you go through these loops? How fast can you build? How fast can you measure? and how fast can you learn. So ideally, you should be optimizing how fast you learn in this loop, right? And this comes through three broad principles from an Amazon perspective. One is design thinking, second is to build an agile team, and third is through the ability to build a DevOps kind of a environment. So we'll jump through these as well. Within Amazon, we have very specific terminology for this, but broadly, if you look at the industry, these need to be connected, and you need to build an organizational flow that kind of optimizes your learning cycle. So design thinking is nothing but user-centered design, right? You need the ability to actually gain empathy and insight of your customers through direct observation. You need to frame your problems from your, what you're trying to do is you're trying to frame problems from your user's point of view. You ideally, when we try to do this, we try to build a solution that is in search of a problem. Instead of that, you need to be able to figure out what the real problem is, right? The other one is, you should be able to generate ideas that solve that particular pain point and be able to deliver that quickly to the customer for you to be able to demonstrate and see them use it in a real world environment. You should be able to conduct simple, fast, and frugal tests with real users. Sometimes this may not even include building a product, but it could be doing something completely offline. So this is design thinking, right? Now, to be able to do that and to be able to respond quickly to user feedback, you also need to build an agile team. So the focus is to be able to respond fast and to be able to learn over following a plan. So there are multiple frameworks that are out there that, software, if you're building software, right, you could be using extreme programming, you could be using Scrum, Kanban, and so on. But each agile framework has a way of, bringing feedback into the work stream and learn from, what you're building. So I've taken one example of Kanban because I've used Kanban in the past. So the idea here is to be able to, get your tasks prioritized, build a backlog, and based on user feedback, create a prioritized log that you can work on. Move that to a work in progress kind of a stream, a band with certain limits. You don't want to build too much as well and spend too long, right? So you need to time box how long do you spend building something and how much are you building for each sprint, right? And then get that work product out as fast as possible to the customer and get feedback back into your team to generate more insights. So this is around agile teams, right? And the third principle that we speak about is DevOps. Again, what DevOps does is to be able to build really fast and promote and enable fast feedback. So how do we build fast? We try and automate as much. What we say is automate all things, which may not be possible, but automate as much as possible. When we talk about DevOps, we also talk about eliminating handoffs. So when you try and build something, don't build silos of teams that are handing one thing to the next. That creates problems in terms of you building and delivering something to your end customers. And the third principle that we need to be aware of is to be able to establish the right guardrails. What you're doing in DevOps is for empowering teams to move really fast, right? But as teams try to move really fast, they can step on each other's toes as well, right? Sometimes you may give somebody access to, say, production inadvertently, and that can cause problems. Or sometimes somebody is building something that does not integrate well with another service that is being built by a second team, right? So establishing a guardrail means, creating the right standards or APIs that does not change, or creating a guardrail around what infrastructure can be accessed. creating guardrails around security, what can be accessed by your teams, your end customers, and so on and so forth. So these three principles are important for you to build the right organizational flow as you try to generate insights from your customer. So how does Amazon achieve this? We have our own internal terminology for doing this, right? Our user-centered design model is based on something we call working backwards. All of our teams, we spoke about 180 services, right? Each team is maintained by a team called a two-pizza team as of today. A two-pizza team is basically a team that can be fed by two pizzas. No team is bigger than a two-pizza team within Amazon. And the third is moving to a model of microservices that improves speed and agility, and it automatically adds DevOps capability within an organization. We'll look at this in more detail. So this is something that that I learned after I joined Amazon. I wish I had learned about this even before when I was an entrepreneur. So how do we work backwards, right? So some very interesting practices that we have in Amazon is, even before creating a product, we write a press release. So imagine you're creating a product, right? And you're going to launch this tomorrow, and you want to send a press release to blogs and newspapers and so on. What would you write in that press release is something that we write even before we start building. This allows us to think big and focus on what the customer really needs. So when you try to articulate your problem or the product that you want to launch in the form of press release, it allows you to really focus on what the customer needs. And a press release is then reviewed by multiple teams and brainstormed around. The second thing we do is we actually write an FAQ for the product even before we build it, even before we write a single line of code. We write an FAQ for the end customer, talking about trying to preempt all possible questions that a customer may ask. We also write an FAQ for internal stakeholders like a support team, like a production support team, right? To address all possible questions that an internal stakeholder may ask. This again kind of helps you think or dive much more deeply into what you're trying to build and what benefits it provides and what could be what are the potential problems that customers may have, and elicit what it is that you're trying to build. And lastly, we always define user interactions and write the manuals for our products even before we start building. We create low resolution prototypes, like we draw stuff. We don't even use software. We draw things in sheets of paper, and that gets discussed even before we start building. So this allows us to work backwards even before we start building something. But as we build, we then continuously push that product over to the customers, and we get that feedback loop back from the customer through support channels and through solution architects and so on, and we continuously iterate on the product. And all of this is done by very small teams that we call two pizza teams. These are all small and decentralized teams that are really nimble. All of them maintain, say, one particular service. They own and run what they build. So it's not like traditional organizations where you create a development team, and then there is a testing team that tests, and then there is an infrastructure team that deploys, and then there's a support team that supports customers and so on. What we do is the team that builds actually does the production support for that service as well. That way they get to know the real problems that customers face in using a particular service, right? And this also builds the DevOps culture within the organization. And lastly, we build everything as a microservice. Now, this may not be relevant for a very early stage startup, but as you scale and grow And when you have multiple teams working on different parts of your application, it becomes a lot easier if you are building something as a microservice. A microservice is basically something that caters to one single purpose or function of a product. It is usually API based. It will have a well-defined API, and all other parts of the system will only use that API to consume that service. There is no way in which a database or something that a particular microservice is exposed to another service, through internal mechanisms. Everything goes through an API, and these are all highly decoupled. And when I say highly decoupled, one of the anti-patterns that I see quite often with many customers is that even though they start trying to build a service-oriented architecture, services try and connect to the same database. The persistent layer is usually something that is shared across multiple services, but that is an anti-pattern. Ideally, when you build a microservice, each microservice has its own database, and access to that database is only through the API that you expose for that microservice. And this enables you to work in a clear DevOps kind of a model where a single small team can maintain that and support that service and deploy that service end to end. And it allows you to build features much faster and get your features out to your customers. So how does the cloud enable all of this, right? Many of these could even be easily done in an on-prem environment. But what the cloud does is it reduces the cost of failure. Today, you can very quickly build a solution, a machine learning model and run it on GPU for a day, right? And you can quickly bring down that infrastructure if it does not work, and you'll only incur the cost for that particular day. Basically, what the cloud does is it moves from a CapEx model to an OpEx model, right? So take advantage of that part of the cloud, right? That capability that the cloud brings. Secondly, it allows you to rapidly adopt new capabilities. Today, cloud providers are moving at an extremely fast pace, and AWS launches hundreds of features almost every month. And every reinvent, you would see more and more features getting launched in machine learning and analytics and so on. You have the ability to adopt these new capabilities and build those into your products and services. And the third capability is you don't have to build something that only caters to a small user base. It's possible for you to build something that caters to a few users or even a million users within a moment's notice. You have the ability to scale those ideas using cloud infrastructure. So using something like DynamoDB and Lambda, for that matter, allows you to very quickly scale from just a few users, maybe 100 users, to millions of users, and you only pay for what you actually use. So startups need to really think about using some of the capabilities that the cloud brings to the table, and take advantage of what's available out there. So next, how do you, now that you've understood the services that are out there, there are reference architectures that you can look at, there are solutions that you can potentially, explore and build your own as well. These are some of the things that you can read to understand these in more detail. There are also some links that allow you to, create an account and start a free tier on AWS. Setu spoke about the Activate program, which is available for startups, where we provide promotional credits and support and so on. So you could potentially use that to, take advantage of some of the credits and start experimenting on AWS. You can use forums within AWS to ask your questions and, get responses to any issues that you face or any doubts that you may want to clarify with respect to services and solutions and so on. And last but not the least, you have the ability to actually reach out to a solutions architect to come and review your architecture. Look at what you're building today and give you advice on how could you do it better. How could you do it with a much more optimal cost, or how could you make it more secure, and so on and so forth. So with that, I end my session and happy to take questions.
Hi, if you could, if the attendees could start putting up their questions either in the chat box or on the Q&A, we'll try and read those and, answer any of the questions.
No questions. You can also come on video. Happy to chat.
Yeah, if somebody wants to get on to, ask a question in person, let me know. I'll give you the permission to kind of talk. Just mention in the chat box if you want to, you can just mention in the chat box if you want to, if it's difficult to type out a question and it's taking too long or anything. Okay, so there is one question here. What kind of value addition do we get with AWS Business Development Team? This is from Kotesh. It's there in the Q&A box, Satish, if you want to.
All right. It's something that Setu can add more, but what Setu had shared is what the business development team provides. You may want to explore something called the AWS Activate program, and this is this is being done with the BD team as well, and the business development team actually works with accelerators like Clarion and VCs to help cohorts of startups, and we provide promotional credits for you to utilize. There are also other things like if you want to go to market to some of our given that we serve a large base of customers, we can actually, if you're building say a solution, an ISV kind of solution or a SaaS solution, we can help you go to market and reach out the larger base of customers. We can even connect you to other accelerators and so on, VCs and so on. We, if you're building something for enterprises, we have a program called Connections, where we do matchmaking between a startup and an enterprise, and then you could actually demonstrate your solution to enterprises. We do connect you to support as well, so that if you have any questions with respect to using AWS services and so on, we can connect you to technical support. There are also a few other things. Setu, do you want to add anything more to it?
I think Satish, you covered everything, but majorly the AWS Activate program, which is available to startups that are part of Clarion call. So you can reach out to the team for more info on that. You get a certain amount of credits through it. That also includes business support credits as well. Then always you get access to a solution architect for a review or any other technical support that you require.
Cool. So that was one. I just thought, maybe it's a very basic question because I'm a non-technical person, but I was just wondering, when we were going through the jury selection process, a lot of the startups that were part of the Clarion call were D2C kind of companies trying to sell products directly to customers. So I'm just wondering if, their requirements would be a little different. I'm sure they're covered under the umbrella of things that you spoke about. But if I were to just talk about the building blocks in terms of a early stage D2C company thinking about how they could use AWS, what would you say?
Yeah, that's a good question. So when you look at a D2C company, they're actually trying two things. One is, it's like an retail e-commerce space, as well as manufacturing. Like they have products that they are building, and they want to distribute, get those products out to customers. So many of them I see are trying to build e-commerce kind of infrastructure. There are solutions for doing this. Secondly, as D2C companies scale, there is a need to one, optimize their supply chain, or make it more efficient. So there are solutions that cater specifically to supply chain within AWS that they can explore. The other thing I can think about is the other challenge that D2C companies have is to be actually to connect with their customers, right? The end customers, and see what is it, what is their unmet need, and how do I support them better. So there are solutions where you can set up a cloud-based call center. There is a solution called Amazon Connect, where you can set up a full cloud call center, and you can see what calls are coming in. You can apply machine learning on top of it to understand patterns in the kind of problems customers are facing. So all of this can be used for D2C kind of companies. Apart from that, you may also want to talk to Amazon Global Selling, which is a different organization, which is not AWS, which help D2C companies go global. So that is something that, that's something under the Amazon portfolio.
Understood. There's one more question that has come up here, which says, considering cloud solutions are highly available, what is the importance of having a DR setup?
Well, availability and disaster recovery are actually two different things. Availability is actually, it's like, let's say one center goes down, and see, one of the things that we also keep saying all the time, right? Werner Vogels, our CTO, says everything fails all the time. It can, even if it is AWS, it fails, right? We keep seeing problems in terms of infrastructure. It could be sometimes a network. Yeah, Airtel may go down, right? And you may not be able to access the solution itself. Now, availability helps you set up your service in multiple AZs and things like that, so that things are available for you. But imagine there is a wide scale disaster. Let's say our region is in Mumbai and there is an earthquake, and all of our everything is down, power is down, right? That is a disaster. Now in a disaster recovery scenario, what you have within AWS is you can take backups of whatever you're doing and host it in a completely different region. It could be Singapore for that matter, and again, and quickly make that available for your customers. But it's not like immediately available. So you have the choice of, there's something called RPO and RTO, recovery point objective and recovery time objective, that you use to assess how quickly you want to respond to a disaster. So if it is like, if you want to get something up and running within 30 minutes, so your RTO is 30, and you have a setup in Singapore that where you go and click a button and your services become available within 30 minutes. So that is disaster recovery. I hope I answered.
Yeah, there doesn't seem to be any follow-up on that. So just checking again if somebody wants to kind of, okay. Yeah, so yes, I got a response saying that yes, it got it. It's in the Q&A box.
Yeah.
Any other questions from any of the attendees? Nope, I guess that's pretty much what we have. Thank you very much, Satish. I think there was a lot of material, and I think once Sandeep uploads this on the Clarion Call I Am Calcutta Association YouTube channel, many more people will see it over a period of time. So it will be useful for others. And I think thanks Setu again for talking about all the possibilities for startups in terms of getting started with AWS and scaling with it. Yeah, so that's it from our side. Thanks to the attendees and the panelists.
Thanks, Kashyap and Sandeep, for having us.
Yep. Thank you.
Yeah.
Bye.
Thanks, Kashyap and Sandeep.
Thank you all.
Thank you all.